Hi guys, today we are going to talk about one-to-one functions. But before we do, let's go ahead quickly and remind ourselves, well, what is a function? A function is a special relation where each input has exactly one output. Now, on that note, well, what is a one-to-one function? Well, one-to-one function, as in the word, it's a function, okay? But it's not just any function. What's so special about this function? A one-to-one function is a function where each output corresponds to exactly one input. So for a function, it's a special relation where for each input it corresponds to exactly one output. For a one-to-one function, we have to be a function to begin with, but what's so special about a one-to-one function? Well, it's a function where each output corresponds to exactly one input. But maybe I could have just drawn it the same. Okay, but yeah, I don't know if I confused you more than I helped you, so let me go ahead and try to illustrate with our first fun problem. So it says fun problem, determine whether each function is one-to-one. Okay, so we are told right off the bat that these are functions to begin with. That's nice. Now all we have to do is verify, are they one-to-one? So then I have to remind myself, well, what's a one-to-one function? So a one-to-one function is a function where for each output, it corresponds to exactly one input. So for problem A, when the output is 5, the input is 1. Same thing when the output is 3, input is 2. What I want to point out is that in problem A, for every output, it's going to correspond to exactly one input. So in this case, we do have a one-to-one function. So let's go ahead and put one-to-one function. Fantastic. Problem B, so we have the domain on the left, which is our inputs, and the range on the right. So I want to know, is this bad boy a one-to-one function? And I'm like, I don't know. Does every output correspond to exactly one input? And in problem B, that is a lie. When the output is -3, the output is either -2 or -1. And every output needs to correspond to exactly one input. So in this case, this is not a one-to-one function. So let's go ahead and write that, not one-to-one. For the grand finale, given that I don't have a table of values, it's not as straightforward for me to identify if this bad boy is one-to-one. So what I'm going to do, I'm going to focus on the output values and make sure that they correspond only to the input values. So the output values are going to be 0, 1, -1, 1. I think we had just said 1. So let me go ahead and circle this. Okay, so we have 0, 1. And then we have 2, 1. So what is going on? When the output is 1, that's going to correspond to the input of either 0 or 2. Okay, so what is a one-to-one function? So a one-to-one function is a function where for each output, it's going to correspond to exactly one input. And in this case, this is coming from more than one input. So this one is also not one-to-one. So not one-to-one. Cool. So are we done? Of course not. So we're still going to continue our one-to-one function unit. But in this case, we are going to talk about the horizontal line test. So back to an earlier unit, we had talked about the vertical line test. And the vertical line test is a visual way to identify if a given graph is the graph of a function. If we were asked to identify if these are functions, the vertical line test says this. If we take a vertical line and slide it across and make sure it doesn't touch the graph in no more than one place at any given time, then this is the graph of a function. So this bad boy on the left, it is a function, but that's not our question for this section. This graph on the right, the vertical line is touching the graph in no more than one place at any given time, so function. But we're done with that, so let's go ahead and go on to this next unit. We want to know, do these graphs represent the graph of one-to-one functions? Well, how can we do that? Vertical line test is for functions. New to our life, horizontal line test. Well, how does that work? So as you guessed that the horizontal line test requires that we take a horizontal line. Yeah, my famous popsicle stick. So the horizontal line test says this. We're going to take the horizontal line and slide it down or up if you want, and make sure that it doesn't touch the graph in no more than one place at any given time. And if it doesn't, then that graph is the graph of a one-to-one function. I think that was too many words. Sorry about that. Okay, so let's go ahead, take our horizontal line, slide it down, and hopefully it doesn't touch the graph in no more than one place at any given time, and in this case lies. Okay, so this graph, so this horizontal line, because this horizontal line touches the graph in more than one place at any given time, then this graph is not the graph of a one-to-one function. Okay, what about the graph on the right? I don't know. Let's go ahead, take our horizontal line, slide it down or up, and we notice that the horizontal line does not touch the graph in no more than one place at any given time. So this bad boy does represent the graph of a one-to-one function. Cool, but now it's time for you to shine. Okay, so we are asked to use a horizontal line test to determine if the function graphed or defined is a one-to-one function. So I want to point out the graphs are given in the first three problems, and in problem D, it's your turn to use the graphing calculator. So horizontal line test, what do we use it for? We use it to determine if the graph is a one-to-one function. So let's go ahead, bust out a horizontal line, slide it down or up, and see, and hopefully it doesn't intersect our graph in no more than one place at any given time. So I'm looking at this one because this extends to this one. Okay, so we slide it down and it's like, lies. Okay, so because our horizontal line intersects the graph in more than one place at any given time, then this graph does not represent the graph of a one-to-one function. So we're going to say not one-to-one function. Fantastic. Problem B. So let's go. Yeah, you can't see that. Sorry. Okay. Problem B. So I want to know, does this bad boy represent the graph of a one-to-one function? Same speech. We're gonna take our horizontal line, slide it down in slow motion. Beautiful. It's touching the graph in no more than one place at any given time. And looks like this graph did pass the vertical line, the horizontal line test of flying colors. So this graph does represent the graph of a one-to-one function. Cool. So the first one is no, the second one is yes. Problem C, does this graph represent the graph of a one-to-one function? So again, one-to-one function, horizontal line test. Regular function, vertical line test. So we're going to take our horizontal line, and as you can see, this graph fails the horizontal line test because we have a horizontal line right here. Okay, so to answer the question, this one is not one-to-one. So now for problem D, let's go ahead, take out our calculator. Okay, so I found my calculator, so let's do this. So I'm going to give you that for problem D, we don't have a graph, but the function is defined. I'm going to give you the popular wrong mistake. I shouldn't do that, but I'm hoping that if I do it, you won't do this, okay? So the popular mistake is that we're like, okay, we have x squared plus absolute value of x. So remember, absolute value, you got to put, where's my fake calculator? Oh, I think it's right here. Okay. So for the absolute value, we are going to hit math. And then we're going to hover over to the number tab. And then it's the first option, ABS for absolute value. Okay, so we have x squared plus absolute value of x. So again, if you don't have the vertical bars, then your calculator will have the letters ABS, open parenthesis, you put x and then you close the parenthesis. Okay, for us, we're gonna go ahead, get out of the vertical bars or absolute value bars, and I know how I will read this. I will read this as x squared plus absolute value of x over x, which is read incorrectly, which kind of makes sense why I will punch it in incorrectly. Okay, so then we put divided by x, and then I graph it, and then I check the graph against the back of the book, and then I'm like, wait a second, that doesn't look like the book's graph. And well, that's because I didn't enter it correctly. So for problem D, what we have is we have a sum and we're dividing it by x. Let's go ahead, look at our calculator and see if we're actually dividing the sum by x. So in this case, I'm going to notice as what is it that I have before and after the division sign. Before the division sign, this is my way, okay? Before the division sign, I only have the absolute value of x. I don't have the entire sum. So if we want to divide the entire sum by x, then we're going to have to use grouping symbols. So if you know how to use your insert function, you know, you do second insert, and then you put your parentheses. If not, you can just clear it, okay? So because we have more than one term in the numerator, we're going to have to wrap it up. So open parentheses, x squared plus absolute value of x. Let's go ahead, clear the grouping symbol. So we have close the grouping symbol, my mistake. Let's go ahead, close the numerator, and then we can safely divide it by x. Cool. Alright, so then for the moment of truth, does this bad boy represent the graph of a one-to-one function? So if we're given a graph, then we're going to use the horizontal line test. So let's go ahead, take our horizontal line, slide it across, make sure it doesn't intersect the graph in no more than one place at any given time. It looks like this horizontal line is touching the graph at most once at any given time. Okay, so it looks like this graph did pass the horizontal line test, so this graph is the graph of a one-to-one function. But you know my style, whenever I use a calculator, if I have a graph, I like to take a screenshot, a very quick screenshot. So in this we have the x and y axis. It looks something like this, something like this. And yeah, we're supposed to have open circles here because the denominator can't equal 0, but it's okay. That's it. Okay guys, so we are done with both sets of fun problems, but don't worry, I'm gonna do more problems in a bit. Thanks guys.